Hello guys, welcome to CSES group. Now we'll be discussing for 2015 circuit theory problems from UPSC CSE mains electrical engineering optional. Okay, तो अभी कोविड की वजह से हर जगह पे लॉकडाउन है. Okay, आपका कोचिंग सेंटर बंद है, कॉलेजेस बंद है, एवरीथिंग इज क्लोज्ड, पूरी दुनिया बंद है. So this is the high time to prepare from home. और इलेक्ट्रिकल इंजीनियरिंग के लिए मैं जितने सब्जेक्ट्स हैं उस सारों को कवर करूंगा और आपके लिए वीडियोस बनाऊंगा. अगर आपको लाइव सेशन चाहिए रहेगा तो आप प्लीज कमेंट बॉक्स में कमेंट लिखिए. चलिए चालू करते हैं 2015 की सर्किट थ्योरी प्रॉब्लम्स के साथ. The first problem for this is, for the circuit shown in the figure, evaluate the current through the voltage across the element. Okay, so you need to write down the current values and the voltage values for all the elements. So how many elements are there? This is the first element, 10 ohm, the second one is 20, and the third is the capacitor here, right? So you need to calculate voltage across this, current through this, voltage across this, current through this, and voltage across the capacitor and the current through the capacitor. Okay, so this is a sinusoidal steady state problem. You need not to bother about what is the initial condition here. Please remember guys, whenever you are having SS problem, okay, sinusoidal steady state, then you need not to bother about the initial condition. Okay, so initial condition is immaterial now, because now your circuit is in no initial condition. No initial condition, please make a note of it. If that is the case, you need to just apply the simple KVL KCL to it. Okay, and you can easily get the answers. So I am writing loop equation for the first loop. Okay, the left hand side loop, this one, and the other loop here, and I am writing the current notations in this way. The current flowing through this 10 ohm resistance is I, through this 20 ohm is I1. Okay, look at here please, and through this capacitor it is I2. The voltage, the source voltage is given as 173.2 at an angle 0 degree, which can be written as 173.2 plus 0j. Okay, why I am converting it? Because all in the form of a plus jb. Here it is a plus jb form, but whereas this is in magnitude and angle form, so I am changing that to the same format. Okay, now let's write the equation. Yeah, so the equation is minus 173.2 at an angle 0 or plus j0 plus 10i, that is the voltage across this 10 ohm, plus 20 into this 20 into I1. Okay, so I1 can be written as I minus I2. See, three unknown loge, then you need to look for three equations. Okay, so this is the third equation. So I am using it the first step such that I will end up with only two unknown. So two linear equation and two unknown. Okay, so that's why I am replacing here the I1 value. If you simplify it, you will end up with 173.2 is equals to 30i minus 20i2. Okay, that's the equation number 1. Now let's move to the equation number 2. For that you have to take this second loop. Okay, let me clear this. Yeah, let's clear this guys. Yeah, now this is done. Now the second loop equation comes out to be 20 into I2 minus I1 because of this resistance, plus minus of J11.55, that is 11.55. Okay, minus sign is already there, so you have to take that one, is equals to 0. So simplify it, you will find minus 20i plus 20 minus J11.5 I2 is 0. So that's equation number 2. So two linear equation and two unknown, you can simply calculate the current out of it. Okay, so if you solve that, you will end up with I is equals to 8.65 plus 4.99j and I2 is 4.32 plus 7.49j. From this two values you can calculate I1 also. Look at here, the I1 is I minus I2, hence I1 can be identified or calculated from that, which is 4.33 minus 2.5j. Okay, now you have to calculate for the voltages. So voltage across 10 ohm resistance is 10 into I. Okay, so 10 into I is 86.5 plus 49.9 G. Voltage across 20 is 20 into I1. The current flowing through 20 ohm resistance is I1. So let us multiply that. And that's what the answer after multiplication. And the voltage across capacitor is the capacitance value, that is minus J11.5 multiplied with the current flowing through it. Okay, so that is I2. If you do such calculation, you will end up with 86.5 minus 49.89 J volts. Okay, so this is what the complete answer for the question. Okay, so we have calculated the current and the voltage across each branches. Next question is, that is question number 3C. If two-port network has Z parameters as this one, two such networks are connected in cascade, what are the overall Z parameter of the complete circuit? Okay, so this is what the simplified diagram. I have one network and the other network connected in cascade. Okay, please remember guys, when two networks are connected in cascade, their transmission parameter, the ABCD parameters, are simply multiplied in a matrix form. Okay, that's very important point. So what we will do, we will divide the equation into three steps. So we will be first calculating the ABCD parameter of these two networks. Since both are having same Z parameter, so same ABCD parameter will come. Then we'll multiply the ABCD parameters with each other using matrix multiplication. And the third step, we will convert back the ABCD into Z. Okay, so let us first convert the Z into ABCD. So I am writing for your reference. In my previous lecture, I have already discussed how to memorize and how to convert that into each other, right? So Z into ABCD and ABCD into Z. So I'm writing here for your reference. Now A is Z11 divided by Z21, B is delta Z divided by Z21, C is 1 upon Z21, and D is Z22 divided by Z21. Okay, so let us substitute these values and you will find A is 1, B is 0, okay, and C is 0.005 and D is 1. So let's write in the matrix form. Then once you are having that, see here matrix multiplication I am writing. So once the matrix form is done, you just multiply them, and this is the overall ABCD parameter of this network. Okay, this network complete. But what is required in the question, you need to identify the Z parameter. So now convert this ABCD into Z. So that's I'm doing now. So overall ABCD parameter for the current network is here. Now conversion from ABCD to Z is written here. Okay, so this is what conversion from ABCD to Z. If you substitute these values in this way, you will end up with Z11 is 100, 12 is 100, 21 is 100, and 22 is 100. That's all for this question. The next question is, the network shown below, determine the value of current through 1 ohm resistance connected between the terminal A and B. Verify the answer using superposition theorem. Okay, so where is A and B? This is the A and B. So here a 1 ohm resistance is connected. You have to calculate the current which is flowing here. Okay, and then you have to verify this using superposition theorem. So let us calculate that. Now I'm writing the current for this 2 ohm branch as I. Okay, and for this 3 ohm branch it is I plus 2I. Why I am writing so? Because you are having a current source between these two branches. So obviously if this is I current, that is 2. So using KCL you will find that the current flowing in this branch is I plus 2, and hence in AB branch also. So let us write the KVL loop equation for these two, for this complete loop. Okay, so what is the loop? It is A, then you are going to B, then you are going to C, and then the D. You cannot write the loop equation for this loop and this loop because you are having a current source. So whenever there is a current source, you cannot write the voltage across it. Okay, Hence I am considering the outer loop now. So if you write so, you will find the loop equation is minus 4 plus 2 into I1 plus I plus 2 into 3 plus 1 into I plus 2. Simplification of that will yield 6I plus 4, which is I is equals to minus 2 by 3 amperes. Okay. Now we are looking for the voltage and the current across this I1. The current through this 1 ohm resistance is I plus 2. I is equals to minus 2 by 3, and thus the current is 4 by 3. Okay, so here it is. Now you have to verify your answer using superposition theorem. So what is the superposition theorem? I have taken from this web source. You can even refer to any good book also, whatever you are having. So what is superposition theorem? The total current in any part of a linear circuit equals the algebraic sum of current produced by each source separately. So what it is saying, let me first clear this for you. Okay. So the theorem is, if this source is acting alone, then you will find some current here. Okay, let us call that I1. If those source is acting alone, then you will find some current I2 in the branch AB. Okay, if both the sources are acting together, then the current through I1 ohm is algebraic sum of I1 plus I2. Okay, that's what the statement of superposition theorem says. So how to verify it? You know what is the current when both the sources are acting together. Okay, so that we have already identified, that is 4 by 3. Now one by one we need to consider. Let us consider that only 4-volt battery is connected. Okay, and the current source is replaced by the open circuit. So the equivalent circuit is here. Okay, so let us apply the KVL here. So you will find 4 is equals to 6I1, and I1 is equals to 4 by 6, that is 2 by 3 amperes. In the next step, what we will be doing, we will be short circuiting this voltage source, and we will only consider this 2 ampere current source. So the equivalent circuit would look like this. Now you can simply use the current divider rule. So I am using the current divider. So 2 multiplied with the resistance of the branch in which you are not interested, that is 2 here, divided by the total resistance. Okay, so 2 plus 3 plus 1, that is 4 by 6, which is 2 by 3. So algebraic sum, both are in the same direction, moving from A to B, so both are positive, and hence the algebraic sum comes out to be 4 by 3, and that's what the answer of your previous part also. Hence we can write, by comparing equation number 1 and 2, the answer is verified using superposition theorem. Thank you guys for patience. Please put the like button and please share this video. If you like it, please give the comment in the comment box, such that will give me the motivation to prepare for the rest of the subjects. And based upon your request, even we can go for the live session for such kind of subjects also. Thank you.